stand by. Recording. Woohoo! Let's see how well this works. So I'm going to try recording the lectures for the rest of the semester. And I'll be posting those online on Blackboard. If you would like the file for them, let me know. And I'm happy to email you the file or drop it in Dropbox or something like that. They will be their video files, so they will be big. But they'll be uploaded to YouTube, so you can watch them at your leisure on Blackboard. And I thought that would, hopefully help you out a little bit. 2, 4, 6, 8, 10, 12, 13. Okay, so we have kind of, I'm not exactly sure why, but we have a little bit of a drop of attendance this today. Made sense on Monday. A few people got confused and were like, oh, I thought we had Veterans Day off. Nope. We had Veterans Day off, but the problem is Veterans Day was which day? Sunday. Exactly. So, what have we been talking about? Minerals. We've been talking about rocks and minerals and focusing on minerals. And we're talking about mineral identification. What are some of the properties we've explored so far, and how do we determine them? Yes, Veronica.
Naturally occurring.
Excellent. Oh, so minerals are naturally occurring. So those are characteristics of minerals, and there's 5 of them. So one of them is naturally occurring. What's another one? Huh?
Solid.
Solid. Excellent. Crystalline structure. Excellent, Kendall.
Inorganic.
Inorganic. Excellent. Excellent, Catherine. And what's the last one? Huh? Definite composition. Excellent. So those are the characteristics of minerals. Now what I'm looking for, I know the question wasn't 100% clear, are the properties we use to identify minerals, which is what we ended on last time. So cleavage. How do we determine cleavage, Kendall?
With a hammer.
With a hammer. Awesome. Bash it. Excellent. So what's another one?
Fracture.
Fracture. Excellent. So Catherine, what's fracture?
It's when you bash it and then there's no smooth surfaces where it broke off.
Excellent. No smooth surfaces. So if it has even one smooth surface, that counts as cleavage. If there's no smooth surfaces, everything is irregular, then we're talking about fracture. Excellent. What's another property?
Color.
Color. How do we determine color?
Look at it.
Look at it. Excellent. What's another property?
Gravity.
Specific gravity. How do we determine that one? We have to. We bounce it around in our hands. Excellent. And what's the last ones that we covered?
Streak and luster.
Streak and luster. So what's streak? Yeah, you rub it on what?
Pastel plates.
On a streak plate. Excellent. We rub it on there and we see what color. That's powdering the mineral. So that lets us see what color the mineral will be when it's powdered, which is not always the same. Which mineral was a different color when it was, or which specimen was a different color when powdered on the streak plate? Number 5. Excellent. And then luster. What's luster? Metallic or non-metallic. So it's the type of shiny it is, and we're only focusing on metallic versus non-metallic. So, and how do you determine that one? With our eyeballs. Take a look at it. Excellent. So I'm going to go ahead and I'm going to distribute the trays, the mineral trays. So I think you already have one up here.
My group's not here, so I'll just wander.
Wander. Okay. So wander over here. So this is your tray. Tray over here. I know. The noise is terrifying. You have one. Are you guys going to work as one big group? Awesome.
A few of them. Yeah, they have some of them there. I got mine at Walmart.
Oh,
And then you can go outside of that as well.
You guys are one big group or a couple of groups? You got your group, you got your group of 2. And then Abigail, are you going to be working with Veronica and Leilani? Excellent. And let me go ahead and distribute the kits. So 1, 2, 3. Everyone gets a kit.
But I didn't really use it.
For your group. And an acid bottle. And what's the safety with acid? What's the rule with safety? Don't eat it. That's always a good rule. You don't want to be gnawing on rocks.
It's not
What's the
actually.
other thing with
Not this
acid?
class.
Don't
It's
get
one
it in
of the
your
ones that
eyeballs.
fixes
You get it on your hands. Your hands, your skin. It might irritate it a little bit, but it's not going to cause serious problems. But if you get it on in your eyes, that you are going to have a very unpleasant afternoon if you do that. Go. Go. We can
Well, I had a different class before that.
Right, they're pre-bashed.
However, they like the week before.
There you go. Everybody got
It's just the time
kits,
Oh, we don't
acid,
have enough students.
ready to go, ready to rock and roll. Excellent. She's
So
here.
I signed up for that.
Awesome. Welcome, welcome, Brittany. I'm just going to check the camera really quick, make sure it's still lined up. Awesome. So let's take a look at some of these other properties. So the one that we skipped over because I wanted to spend a little extra time on it is hardness. Okay? So hardness is resistance to scratching or abrasion. And based on every other property that we've used in this little example so far, how do you think we determine this? We try to do what?
Scratch it.
Try to scratch it. Excellent. So we scratch it. Or we scratch it with stuff. Okay? So, we're going to go into more detail. Next page. Okay, you might want to add that to your notes because that's pretty blank. We're going to actually go ahead. What scale do we use for hardness? Mohs hardness scale. And it's not M-O-E and it's not M-O-W. It's M-O-H. It's a person. M-O-H-S. It's a person's name. So Mohs hardness scale. Mohs hardness scale it's not, they're not evenly spaced, these values. This is not the most technically accurate way to describe the hardness of minerals because, for example, fluorite, which is a 4, is not twice as hard as, say, gypsum, which is a 2. But the advantage of this scale is that it's very intuitive and incredibly easy to use in the field. So most mineral identification books use Mohs hardness scale, and it's still something that we use practically out in the field, okay, to help us identify minerals. So the two tools that we're going to use in order to determine the hardness of our minerals are a glass plate and our fingernail.
Oh.
What do you mean, oh?
It's like nails on a chalkboard over.
It's not going to be nails on a chalkboard. It's going to be nails on a mineral. Okay, so it doesn't sound like anything. So, if we think of Mohs hardness scale, making a number line. So Mohs hardness scale goes from 1, which is talc, which is the softest mineral, talc, and what's the other really soft mineral that we looked at? Graphite. Excellent, Caitlin. So talc and graphite. And it goes all the way up to the hardest mineral, which is diamond. Now if I put the two that we're going to use, fingernail and glass plate, what's the hardness of your fingernail approximately? 2.5. There's a fingernail. And over here we have the hardness of a glass plate, which is 5.5. So we're gonna try and scratch our mineral samples with our fingernail, and we're going to try and scratch a glass plate with our mineral. So, if your mineral scratches glass, what's its hardness?
Or above.
That's a good, or above. Excellent, Brittany. Excellent. So if your mineral, if your sample scratches glass, it is greater than 5.5, and that's a greater than symbol right there. Now, if I can scratch it with my fingernail, I'm scratching it. What's its hardness?
Lower.
Lower. Excellent. Lower. Veronica's got it. So over here on this number line, part of the number line, we say if sample can be scratched with your fingernail, it is less than 2.5. Now, if these greater than or less than symbols, if you're like, I didn't like those symbols even in math class, it's okay to write less than 2.5 and more than 5.5. Both of those are totally acceptable as well. The thing that I'm worried about is you know what range you're looking at, not if you're good with the little less than or equal to sound, less than or greater than sign. Now in this big zone in here, what's going to happen? Yes, Gabriel. It will what? It will scratch your fingernail, but we're not going to be trying to cut into our fingernails with minerals because that would be, yeah, I love the face that Caitlin's making. That's the face I would make, and I'm pretty tough. So, so if the two tests are scratching it with your fingernail and trying to scratch a piece of glass with it, what's going to be this range over here? Yes, Seth?
It's not going to be scratched by your fingernail, but it won't scratch the plate either.
Excellent. Can't be scratched by a fingernail. And you can't scratch glass. And so, how would I describe that hardness between the two of them? Excellent, Veronica. So that's 2.5 to 5.5. Now, in real practical application, glass plate, that hardness is set and fast. Fingernail, everybody's fingernails are a little bit different. So for example, from experience, my experience tells me that my fingernails are a little bit harder than 2.2 because I can scratch minerals that are about a 3, like calcite, with my fingernail. Some people have slightly softer fingernails. So keep that in mind when you're trying to test these guys. So we're going to take a look at sample number 1 and sample number 2 and determine the hardness. Now, one of the big keys when determining hardness is, you know, we're not going to be, you got to be tough, okay? We're trying to be geologists. So when we're trying to scratch something with a mineral, we're not going to go there and be like, oh, I'm going to gently drag it and hope that some scratch shows up. No, I want you, everyone to grab, at least one member of the group, grab your sample 1 and give it a good plump and tell me what happens. Like, put some elbow grease into it.
Yes. And this is perfectly good glass. So, where is it? So it's good.
Excellent. What did we find?
It's a giant, yeah. That's fun.
What did we find, Leilani?
The giant large one.
Yeah, there's a big old scratch on there. Okay, so if you're being tough, if you're being a geologist, roar, geologist, go like this, and we can see that it scratches it. Okay, so you got to put a little elbow grease in there for the harder minerals. So what can we say about sample number 1? Excellent. Has a hardness greater than 5.5. Or if this makes you more comfortable, greater than 5.5. Go ahead and grab number 2. Do both tests. Do the scratching on the glass. Try to scratch glass with it. And try to scratch it with your fingernail.
I don't want to break it.
Yeah, number 2 is the shiny one. It's okay and keep in mind that breaking is not the same as hardness. Breaking, the ability for something to break, is called its friability. That's how easily it shatters. So number 2 is highly friable, so don't mix that up with hardness. So what we're trying to do is we're trying to grind up the mineral with our fingernail.
It's already falling apart.
Oh,
No, let's not break
It's
it.
fragile, but is it, what are we finding? You managed to scratch it? That's possible if you have very hard fingernails.
Oh.
I scratched it.
You scratched it? Are you scratching it, or is it scratching your fingernails? Are you absolutely sure?
No, it's not scratching the glass. It's on it myself.
It's definitely not scratching the glass. So what can we say about number 2? Less than 5.5.
yeah, I can scratch it with my fingernail too.
Is it flaking or is it scratching?
Oh, it's scratching.
Can you show me the scratch marks?
Yeah.
Unless it's a dent by the force you're putting it.
See right there, like that's where I scratched it.
Like in there?
Yeah.
If I go like this, will
I
it
scratched it.
disappear?
just disappeared.
It just disappeared. It's a dent. Yeah, it's easy to bend. It's a little bit harder than your
Oh.
most fingernails. Okay, it's close.
Poor things with torture.
It's close. If you have really hard fingernails, you might be able to scratch it. But number 2 is really greater than is actually between 2.5 and 5.5. Let's do a slightly easier one. Take a look at number 4. Try to scratch glass with it. Try to scratch it with your fingernail. And be careful. Make sure you're checking whether or not your fingernail is actually getting powdered.
This isn't doing
This is number 4. So what do we got?
So weird.
It's only powder.
So weird. Definitely, a lot of minerals are. That's the fun thing about minerals. They're like, this doesn't even look like it should be a mineral, right? This looks kind of like it's plastic.
Yeah.
It's craziness, but it is definitely a real mineral. So, what do we got?
Like you can try water and yeah, it's just like powdered.
You're powdered when are you sure it's not your fingernail?
My fingernails scratched.
I did not scratch it.
You did not scratch it?
the plate either.
It did not scratch the plate. So what's number 4?
Between 2.5 and 5.5.
2.5 and 5.5. It's hard. It's hard to get some practice on this because your fingernail will get powdered. I've had people, grab quartz and tell me like, this is softer than my fingernail. I'm like, no, it's super not. It's definitely not softer than your fingernail because your fingernail will get powdered and that can look like you powdered the mineral. So, makes sense? Awesome. Let's go ahead and go to magnetism. So, some samples are magnetic. And there's a variety of different ways that you can determine whether or not something is magnetic. So, magnetism is electromagnetic force generated by an object or an electrical field. Oh, cool. I already pulled it out. So, one way to do that is with something like this. These are iron filings, okay? And if the mineral is magnetic, and this is a big sample of a magnetic mineral, this is magnetite.
It's an Etch-a-Sketch.
Yeah, it's like an Etch-a-Sketch. It will, of course. Today I have the camera and now nothing is working. So, but I assure you this will, oh look, it powders on the table. So this will gently attract a little bit of the metallic material. However, what we generally use that's a little bit easier to use is a magnet. So we see if it attracts a magnet. So in your kit, there's two different types of magnets. One set of magnets is going to, some people have this kind of magnet, which is a little disc. Other people have like a little tiny, like dark gray bar. Other people have that. Excellent. So I want you to take a look at number 1 and try to stick a magnet to it.
No.
So is number 1 magnetic? No, number 1 is not magnetic.
Oh.
Now an example of a mineral that is magnetic is magnetite. And I'll pass this around with the so you can try and stick a magnet to it. But the classic example of a magnetic mineral is magnetite. And actually, a lot of magnetite it used to be called lodestone, and they used to use it in order to determine direction. Okay, so it was used for ancient compasses to determine direction. Go ahead and pass this around. You can get a feel for how magnetic this is. And the next one, reaction to HCl. Does anyone know what HCl stands for? Hydrochloric acid. Excellent. So now we actually get to use our acid. Okay, so we usually use 5% acid. Okay, we don't use a really, really strong acid. We use the mild acid that you have in here. And how do we tell that a reaction has taken place? Bubbles. Excellent. So bubbles, or fizzes, or effervesces in the presence of acid. Okay, so I want you to drop acid on your number 1 and on your number 4.
Everybody did it.
And remember, you don't have to make a puddle. You don't have to have it go swimming in a vast sea of hydrochloric. A few drops will do it. So what did you find?
Number 1, no. Number 4, yes.
Excellent. Number 1, no. And number 4, yes. Now there's some other properties that, special properties that we're not going to use a whole lot in the laboratory and in the classroom. One of those is symmetry. Symmetry is the geometric shape of a crystal or mineral. So we have 2 other terms to describe shapes and minerals. What are the 2 other terms?
One of them tastes like salt.
Okay, so we're not on taste yet. We're on symmetry. I'm talking about shape. So symmetry is one type of shape. What's another property where we're looking at the shape of the mineral? On the property list. Cleavage and fracture. Excellent, Catherine. So cleavage and fracture. So a question students have is, what's the difference between cleavage and fracture and symmetry? Symmetry is how the crystal grows. Whereas cleavage and fracture are how it breaks. Okay? Now all your samples are already smashed up, so are they good for determining symmetry? No. Okay? So you can have a mineral that has beautiful symmetry, okay, when it grows, and absolutely no symmetry when it breaks. So I'm going to grab some crystal symmetry. So did number 1 exhibit cleavage or fracture? Fracture, excellent, which means it's super irregular. So we're going to take a look at number 1, and we see that it's really irregular here. Here are the 2 examples before of that same mineral before it was broken up. And we can see that it has this beautiful 6-sided shape as it grows, okay? Now at this end of the crystal, you can still see that irregular fracture where this crystal is broken off of the body of rock that on which it originally formed. So you have this beautiful crystal here, beautiful symmetry, but when it breaks, it's irregular. Same in here too. The mineral, this is the same mineral as number 1, and if you look at these individual crystals inside the geode, you can see that they each have that same 6-sided shape. So that 6-sided shape, if you see an unbroken crystal of number 1, that is one of the diagnostic properties that help you identify it. Does that make sense? Excellent. Let me go ahead. I'm going to pass around the examples of symmetry. Now, there are other ways scientists determine symmetry in other ways. There's X-ray diffraction, for example, where you powder it and then you send lasers through it and see how the lasers bend. And there's many, many, many different complicated ways to describe symmetry. But focusing on what you can do in the field, like you're outside and you're hiking and you found a rock and you're like, what the heck is this? You don't have anything to do X-ray diffraction with, right? So what you need in order to determine symmetry is to basically have an unbroken sample. So number 1 has 6 sides, and all the sides are at 120 degrees. In other words, it makes a perfect hexagon. The size of the different sides changes. Sometimes they're all the same size, sometimes some are smaller and some are larger, but they're always oriented at 120 degrees. Taste! You guys are so excited. You're answering the symmetry question with the taste answer. So taste, how do we determine taste? Huh?
Lick it.
Lick it! You gotta lick it. Excellent. And as a safety note, please don't lick mine. And that's not because I'm like grossed out by your licking, okay? I'm not grossed out by your spit. I mean, I am, like, don't spit on me or something like that. But, like, I'm not epic. That's not why you're not supposed to lick them. It's that these particular mineral samples have been in multiple trays with other minerals that some of them are dangerous, okay? So to make sure that you guys don't get, like, lead poisoning or mercury poisoning or something like that, don't lick things in the lab. However, when you're out in the wild, generally speaking, if it's not a shiny mineral, because most of the minerals that are dangerous are shiny, if it's a dull-colored mineral, it's safe to lick it, okay? So, with that, Gabriel looks very excited about licking minerals. So, what mineral are we trying to identify by licking it?
One of them tastes like salt.
Salt, the one that tastes like salt. So, does anyone know this name, the mineral name for salt?
Sulfur.
No. Sodium.
Sodium.
Sodium, good thought. That's one of the elements in sodium chloride, which is salt. You're thinking of the chemical name. Mineral name begins with an H. That might jog your memory. Halite. We didn't write it down yet. I've mentioned it a few times. We didn't write it down yet. That's perfectly fine. So, if it tastes salty, that tells you that it's halite. In other words, salt. So this is an example of halite right here. Beautiful. This is a broken sample already, so would we say it has cleavage or fracture? Cleavage. It's got beautiful cleavage, and I usually include it in the tray because it is such a beautiful example of cleavage. So this has to do with the way that the ionic bonds between the sodium and the chloride, and it basically makes these little cubes. No matter how far you break this down, it's going to have the little cubes. You can have little cubes down to microscopic level, okay? And it's got beautiful and what's called perfect cleavage because of the ionic structure. Make sense? Excellent. I'm going to pass around the sample of halite. Excellent. Now there are other properties. Fluorescence. What does fluorescence mean? Glows. Now there's a couple types of glow. If it glows, can you lick it? I wouldn't recommend it. Why not? Well, actually, a lot of the minerals that fluoresce are rich in uranium. So that's another thing you don't want to eat or you're going to get weird. Huh? Superpowered. No.
Yes.
Stanley, goodness rest his soul. Large quantities of uranium don't help you. So, fluorescence is glows under UV light. UV light.
I know.
Okay, so you might have a friend, maybe in the dorms, maybe not. Probably their room smells fairly interesting and they have blacklight posters on the wall. That's